You're in church.
Okay, well, good morning, everyone. This panel is to discuss the CI leadership role about assessing and anticipating the researcher needs. And then our panelists for the morning are Patrick Clemens, and then Randy Downer, and Chris Simmons, and Jason Sims. It's like there is a pattern of the last names. And, so I will let them introduce themselves, and we'll start with Jason.
And be loud.
I don't have that issue. And
okay.
I definitely, no one's accused me of being quiet or mouth later in my life. My name is Jason Sims. I'm pleased to be a participant here on this panel. Thanks for asking me. Thank you. I'm the instructional technologist. I guess I should look at the camera here. I'm the instructional technologist at Lafayette College in Easton, Pennsylvania.
My name is Chris Simmons. My background, PhD, is in computational quantum mechanics. These days, I'm director of researcher support at the University of Texas at Dallas, and I'm also a faculty member of the computer science department.
Okay, so Randy and Patrick.
Hi, I'll go next. This is Randy Downer. I am at Colby College, a small liberal arts college in Maine, and I'm the manager of HPC and Advanced Research Computing.
And I'm Patrick Clemens. I am the manager of cyber infrastructure and partnerships with Vermont Ep School at the University of Vermont. But I'm physically located in Portland, Oregon, all the way across the country. My background is in computer engineering, so I have a software background and some IT hiding in there. And excited to be on this panel. Thanks for having me.
Thank you all. And so, Patrick, can you get a little closer to the microphone, just so we can hear you clearly?
I can.
Okay, thank you. So we'll start this panel with like a few questions. So we have like the next 3 slides. Each one of them has like 3 questions, and it will start with like a general question about the discussion. So I'll be sharing the screen. So for the panelists, can you tell us about the vision of the institute, and like how do you deal with like the research needs, and does it change based on the size of the institute, the number of research faculty, and any other factors?
Sure. So at Lafayette, we are a small liberal arts school. Right now we have about 260 faculty, and that's on the rise over the next 5 years or so, going up to closer to 290. That's our vision there. And then we have a handful of other researchers who aren't necessarily faculty, as well as visiting instructors and whatnot. And we try to be very all of them. And so, you know, I'm one of the main conduits of that, although I'm not the only one. But I try to get to know, you know, really anyone who's willing to talk to me. And I think that that's a shared thing that we all have, that, you know, those who are willing to come and meet with us, and we're willing to go and meet with them, and if they're willing to share with us their research and what they want to do, we try to find ways to help them accomplish that. So, you know, luckily we're not so big that we just sort of have to wait for them to come to us. We have a lot of opportunities to engage with them. And I know we have some other questions later that are going to get to this, but we really try to help them from soup to nuts in terms of, you know, everything from their initial vision and planning for what they want to do, all the way through help them with options to make their research visible, discoverable, so on and so forth. So we do have that opportunity to be extremely hands-on and high touch with them for those who are willing and interested to do that with us.
I like his answer. Can I just say ditto? So I was recruited to UT Dallas about 3 months ago. UT Dallas has been on sort of the cusp of becoming a Tier 1 research institute. 15 years before that, I was at UT Austin. And the first thing I did when I joined UT Dallas is sort of write a vision statement for our organization. And our vision is to facilitate and ultimately improve all research on campus and map to computation by providing capabilities in computational hardware, support, and training that are synergistic with national resources. And for those who are coming from institutes that are at the tier 1 level, but might be right outside the top 20, top 30, I think that last part is really important, synergistic with national resources. You know, we have a lot of money invested in the XSEED program, and being at UT Dallas, of course, we have close access to TAP. And even outside of XSEED, we have some collaboration with TAP. So the work we do and the resources we provide try to work in a synergistic manner with TAP. We're not trying to provide just we try to provide fanatical support and training that goes beyond what you can get at a national resource. So we try to focus on things like offering more liberal queue times, more flexible maintenance schedules around paper deadlines, and we try to provide more specialized training for the domain sciences, and really try to catalyze computational science and education by providing sort of 099 classes. So TAP has its introduction to supercomputing classes, but a lot of faculty and researchers are not at the point yet where they can take advantage of that. So we try to focus more on introductory to introductory classes in education to bootstrap them to the point where they're able to take more advantage of national resources.
Okay, so Randy, can you tell us about your area?
Sure, I'm up next. Hi, I didn't say I'm technically trained as a forester, just to be an odd one in the group. Colby is absolutely undergraduate focused, although my, well, to use the four faces, is aimed at the 100 student institution. There are no graduate students, there are no postdocs, even on the faculty size is very close to Lafayette, and we're also growing. As an example, and a change that has happened around here, the CS department has moved from a 2-person staff to so there is a rapid change in who we're focused on. Quickly, I'll pick up on the other questions later.
Patrick?
Yeah, sure. So let me start big. So at the University of Vermont, it's about a 10,000 student kind of public Ivy is what we aspire to be, and you know, a number of doctorate degrees. So it's very balanced in terms of research and graduate students and undergraduates. And I work for a large grant, the Vermont EPSCoR, and it's a $4 million a year grant. We have about 36 researchers. So because I'm within the grant, my focus is very clear. It's to execute that grant. And so the grant's focused on water quality in Lake Champlain Basin, and it's a large computational modeling effort. And so we have about 7 different models that we bring together in what we call an integrated assessment model. And my job is to help the researchers do their own modeling. So we have an economic model and a hydrology model and a lake model and what else? Land use model. And then I have a small team of programmers that help tie all those models together. So mine's a little different in that we have a very specific focus. I don't really deal with the university at large, but we do use university at large resources. We have a compute cluster with a couple part-time FTEs, and we're in constant communication with them in terms of housing some of our servers, and our disk storage is through the university. And so it's a lot of, what my strategy has been is to cobble together a set of national resources, regional, university, and then our own resources, separate sector resources to get our job done. And so when a researcher comes to me, I kind of look at this menu of different scales that we have available to us. and kind of assign those resources as necessary.
Okay. So now we'll move to like more in detailed stuff. So is there a process that you have to assess and anticipate their needs at your place? Like, is there a planned procedure, or is it just like depends on their research and what's going on? You meet with them.
So first, I'll just say, Randy, I don't think you're unusual at all. I mean, my background is in cultural anthropology, so I don't come from a tech background myself. And honestly, I think, as Henry points out, that's not really unusual for those of us in sort of facilitator roles. Many of us in ITS or related disciplines don't necessarily come from a CS or engineering or even a STEM background necessarily. But in terms of the specific question, we have a lot of entry points to getting service and to helping people with their research. Every year we play a vital role in the new faculty orientation. So we have a several-hour block that we are walking, new faculty through what service options are available to them, ways in which we can support what they want to do, whether it's teaching, research, or scholarship related. We give them all of those facets and how we can interact with them in those various ways. But also, it is a lot of ad hoc stuff. So when faculty or researchers or users may submit a help ticket for something, and maybe we've never talked to that person before, but that gives us the opportunity to engage with them directly on what their issue is, and maybe open up a larger conversation about what's going on. We also are trying to get more integrated with our Office of Sponsored Research, so that when researchers and faculty approach them about potential grant opportunities that they would like to see, we can be brought into the fold there as well to process. And as they're creating their data management plans, for instance, or thinking about resources or how to allocate funding that they may be asking for, we can be a part of that process from the beginning and help them move through that successfully. It's also just a lot of so we work with our CIDLs, which is the Center for the Integration of Teaching, Learning, and Scholarship, which is sort of the faculty professional development arm of Lafayette. And we tend to host kind of month with them or in conjunction with them. And that draws a lot of faculty, and that's a place for us to showcase or show off what either other faculty are doing or the new tools that we have in place, and talk about ways in which they can leverage them. And we usually get pretty good follow-up with that, where we open ourselves up and say, look, if you want to do this, come and talk to us. And so that's another way that we kind of engage. So we try to find all of these different methods that we can be available to and reach out to faculty and researchers.
So for us at UT Dallas, historically our campus HPC and researcher group have been mostly a cycle shop, a place to provide resources for campus. But once researchers got access to the system, they were sort of on their own on how to use it and abuse it. And I'm the first scientist who's joined the campus HPC research and computing group. And so when I arrived, it was a combination of FIFO, first in, first out, and the squeakiest wheel, which is not a sustainable strategy. So a lot of what I've been working on is trying to come up with processes to determine priority. For the first couple of months, I've mostly just been working with faculty and working in a consulting role, trying to talk to them about what they're doing, what they should be doing, other resources that they consider using. But going forward, I'm really trying to focus on education first. Trying to raise the level of computational science. So instead of me having to, I'm only one person, and there's only me who's doing the science and software support for the HPC Center. So I'm really focusing on trying to elevate the level of the average student as opposed to bringing down support to their level. So instead of trying to focus on the people who are using MATLAB incorrectly and want to run 1,000 MATLAB simulations, or the person who has their work in ANSYS but they can't afford an ANSYS license to run the larger computations they want. I'm trying to focus on the computational science and software engineering education to bring people up to the point where they can help themselves.
Hi, figure we'll go in just order. I'm ready to go. So I'm going to kind of explain the milieu here a little bit. I've been at Colby for about 10 years. And by analogy, since we were advised to use analogies, doing planning here, anticipating needs, we're like the Roman Catholic Church. That is, we all sit around and discuss things rather than having the deacons from above tell us what to do. One of the other attributes that I'm not going to talk about is the meeting structures that we have for both IT and research computing. Quite honestly, they're reporting out structures, so they really aren't a way for me to anticipate what's the needs are going to be. One of the most important things that I am able to do is to be on the search committee for incoming faculty. During that time, for positions that are computationally intensive, I get to make an initial assessment of where they're going. Then when the offer is made, they are encouraged to come back to me, and together we work on developing their startup package so that it is in tune with the resources that we have here at Colby and yet can extend what they want to be able to do. The other is that departmental meetings throughout natural sciences, as well as other sort of less formal ways of communicating with them. For instance, there's a weekly lunch for bioinformatics. And that's really, really important in order to anticipate out what's going to be happening down the road. The last point is something that Lafayette does as well, which is that in clearing as part of the grant process, they have to sign off on their data management plan. And we've managed to build up a committee of three. That is a librarian, the grants administrator, and myself, to sit down and clear the database management plan. And that is often an ideal setting for working out what their needs are going forward, even if they don't get the grant. And what their anticipated direction is. And that's crucially important to figuring it out. We also do data management plans for onboarding new faculty. That can be effective, but it's much better in the grant. I often sit with faculty to solve specific problems, but that's not really a good way of assessing future needs. It always becomes very transactional. You know, solve this problem. Hey, this directory doesn't have the correct permissions kind of stuff. When in fact, what we should be doing is planning out 6 months, 18 months, 3 years out what their needs are going to be.
Patrick, can you tell us about this?
Yeah, so when I volunteered for this panel, I put a bit of thought into this question, because usually, you know, people come, you don't really think about the process too much. So I actually spent some time thinking about the process, and I think when I get a request, it comes down to assessing three things about the request. It's the details, the user, and then assessing the context. So first, sometimes someone comes up to me and says, you know, I need version 14, build, you know, XYZ of, you know, fancy modeling software X installed on this operating system. And those needs or those requests are, in a way, often simple, because there's not much thought that I need to do, because they've already done a lot of the research on what they need. But then I also get the other extreme of the spectrum where, you know, I need I have all this data, I need to do something with it, how do I do it? And so I think you first have to assess the details. Is it a very highly specific request, or is it something that's more general and you need to do a little bit of research and maybe present a technology that might solve that problem? And closely related to that is assessing the user. You know, I have some users that logging in remotely is a big deal. Like they've never done it before using an SSH shell, or even like a, you know, we have some no machine visual, virtual desktops. That could be a big deal for some users. Other users have been coding in Python since they were, knee high. So I think a lot of times you need to consider the user's ability and the solution that you give them for that problem. You don't want to give a highly technical solution to someone that's not going to be able to use it very well. The other thing about the user too is that even if they have a very specific request, sometimes you have to a person that saw a really great ad for a pharmaceutical, or if they're the actual doctor that knows the pharmaceutical product they're requesting. We get pummeled with all these tech ads, and we see this new technology, and some people are like, I want to use that technology. It's something, something rang a bell in my head, and that's what I think I need to use, when it might not be the right technology for them to use. I think it's our job as a facilitator to assess that technology and decide whether it's appropriate for their requests. So I think you need to keep the needs and the requests at a level of what service are you providing to them, and make sure that the technology that they choose, or the one that you're choosing, is appropriate to that service. And I think assessing the user is an important piece of that. And then finally, I think you need to assess the context. What is important to us in terms of implementation of the solution, and what's important to the user is often disconnected. So I think maybe by practical example is, if you have a monkey in a zoo and they ask for a banana, you give them a banana and they don't eat it. So why aren't they eating the banana? And there's one thing you know about monkeys, is that they really like to watch their food first. So if you give the monkey a banana, which is what they ask for, but you don't give them the water to wash it in, they'll just look at the banana like, what's this for? So I think you need to observe the user in their office or lab actually trying to do what they want to do, because often you see things that they don't think are important details to the solution. So don't forget to give the user the water just because they ask for the banana. Make sure that you know the context of the request and you understand the full scope of it. Watch them try to do it. And oftentimes when you watch them try to do it, you get the aha moment, like, this is why the solution isn't working. It's because you're trying to do it this way, when technically I thought you were trying to do it a different way. So assessing the needs, I think details, the user, and the context are important. And then a little bit about anticipating the needs. I think it's really important to observe the researchers in the natural habitat. Go to their meetings, see them in their social context, and as you see the discussions they have, what's important to them, you start to get a scope of what is coming down the pipe, what is what's going to be important to them in the future months, and you're able to kind of build a mental list of anticipation of what they might need. So I think the most important thing about anticipating needs is getting into their and what details are important to them, and what tasks they might have in mind. And then finally, in terms of anticipation, know your priorities. I have when someone asks me, I have some spare time, I have some bandwidth, what can I do? I can give them a list of things to do. So, I maintain a prioritized list of things that are important to you in terms of like software development and also hardware. And listen for it whenever someone says spend down, because oftentimes you have a grant coming to an end or end of a fiscal year, and someone needs to get rid of money in a grant, and they need to spend it down. And when I hear those words, I always have a list of things. This is what we need in terms of cyber infrastructure. And if you're first to get in the line when you see it spend down, oftentimes you can sneak in a couple extra disk platters, or another virtual machine, or something that's going to help you and your researchers do their job. But if I don't have this list of priorities, I can't be first in line. So it's always good, I think, to maintain kind of this list of priorities and have on the tip of your tongue what's the next critical thing that you might be that might be useful for your researchers.
So like with all of these points that we discussed, we can see that like we need more planning maybe ahead. So we need more time to look at their situations and their problems. But the problem is there is no time. It's always last minute that we try to solve or get them up and running. And like there is a special case with tenure track faculty, which I learned about them at this workshop last year and their problems. And like even as a staff who is on the other end, I noticed that why are these people always on rush and like their plans sometimes are not clear. And I didn't understand, but then it was like, oh, they are on tenure track and they have a limited time, like 7 years, which is really like five years of work, and maybe the last 2 years they need to summarize and publish and all of this. So how do you see this affecting your working with these faculty?
Yes, we have been asked to speak more loudly and more slowly, so I'm going to attempt to do so in my response. Yeah, so interestingly, Lafayette is small enough that we try to provide the same kinds of support regardless of whether researchers are on the tenure track or not. So, for instance, so there are 3 brief things that I'll talk about. The first thing is that with tenure track, within the last few months, I have worked with the Dean of Faculty at Lafayette to become more involved, just as with Colby, with sort of the startup phase. So once they have decided to extend an offer to a tenure track faculty member, I will often reach out if it seems that there's any sort of computational needs or equipment needs or sort of special needs that are beyond just the standard desktop computer and a trash can that we kind of joke about. And I will work with them to figure out how best they can allocate their startup package dollars. So, you know, what do we already have in place? What might we be able to leverage for them that they may not need to account for? And we've never had a process like that before. It's always been rather ad hoc, where they were, you know, where candidates coming in were reliant upon their department chair or other faculty peers to help them through that process. But now we've extracted that out. So that's one way that we're able to provide really targeted support to tenure track faculty members coming in. But then we have other programs, like we have a Teaching with Technology grant program, which is available to anyone, whether they're a visiting instructor, whether they are a 1 or 2 year visiting assistant, whether they are tenure track, whether they're a librarian. If you're involved with teaching in any way, you can apply for a grant of up to $5,000 to buy stuff. That can be a software license, it can be a piece of hardware, it can be stuff that you're going to be using in your classroom, but as long as it is somehow involved with the teaching process, we want to work with you to support that, with the idea being that, and these are given with an eye towards what could be scaled up or scaled out to other faculty members. And so we often have, instructors who come in and they're very high energy and they're excited and they want to try something new in their class. And they have sort of less at stake in some ways because they're not tenure track. So they're willing to kind of try these new and innovative things, and we want to support that as best we can. So this brings me to my third and final point on this, and that is, all that having been said, there is a difference that I see with tenure track faculty. So you're right, they come in and they're on a clock. They're on an immediate clock. And this varies from discipline to discipline, of course, but typically they have to relatively rapidly become productive. So they have to start their research running immediately. They have to start submitting to journals, which may have a 1 or 2 year cycle that is involved in the review process and publishing. So they have to get going really quickly. And unfortunately, one of the things I find there is that it is sometimes more challenging to innovate with those faculty members because they're so busy and they're on such a targeted track that it's not until really they hopefully get tenure and transition into that associate role where they're able to breathe a little bit, and we are able to be a little bit more creative and flexible with them. Because until then, it's just a matter of trying to keep them productive in a positive way that's going to contribute towards their tenure track. But I think we do a pretty good job of that, and we do a good job of not trying to privilege them in some ways, because luckily we don't necessarily have to, given our size and our ability to be nimble in that space.
All right, so when working with faculty, it's always conflict between doing things right and doing things right now. And this is even exacerbated by working with tenure track. Tenure track faculty, especially junior investigators, are coming off postdoctoral, where they worked with either their own software or group software. And when they want to get started and bootstrap a new infrastructure, they're very inflexible or resistant at first. So the first thing I do when I sit down with new faculty is I talk science. I talk algorithms, I talk physics, I talk software, and get an idea of what their ecosystem looks like. Now, I know for not everyone in IT is that a possibility. However, if you're in an IT role and a manager hiring role, I think it would behoove you to consider hiring someone with science and math expertise. And so just by being able to talk science, being able to talk about their PDEs, being able to talk about their algorithms, they gain trust in you. So the first step I try to do is just gain their support and then let them know that I understand what they're working with. Then secondly is then how do you spend their startup money? Startup money is very, very precious as a resource. It might be the largest chunk of money that this investigator receives for a decade. And faculty members always want to just buy what's familiar. Let me just get another system with X number of nodes, 2 gigabytes of RAM per core, no local disk, right to a global file system, let's go. And that type of resource is everywhere. That type of resource is provided by TAC. That type of resource is provided by every X-Seed center. That type of resource, while it might be dedicated to that user, does not give them a new capability. So one of the things I try to figure out when working with researchers is what can we purchase with this money that catalyzes their research, that'll be a good investment, that gives them new capabilities. So for instance, I recently worked with 2 faculty members who had a startup pool of a couple $100,000 they wanted to spend. Well, it turns out that the work they were doing, it's on geophysical imaging, is an out-of-core solve. And what I mean by out-of-core solve is that the algorithm doesn't scale very well in terms of number of cores, so they end up running on a relatively modest number of cores, but needing a large amount of memory per core. As such, there's not enough physical RAM on a system to do their calculation in one go, so they read from disk, write to memory, do a calculation, write to disk, read from disk, write to memory, etc. And they do that over and over again, every iteration of the computation. Now, this type of resource doesn't map well to TAC or other X-Seed systems because you don't have local disks. So you end up doing your out-of-core solves over the global file system. And if you do that, you'll quickly get kicked off the global file system. Several years ago, was tax number 3 on the top 500. Well, I was working on some post-PhD calculations, and I was able to bring that, and it was an out-of-core solve, and I was able to bring down the entire $25 million X-Seed or Teragrid at the time enterprise class system with 2 nodes writing out-of-core solves to disk. So what I did is I worked with these faculty members and designed a resource that is unique for their type of workload, unique for out-of-core solves. It's actually a really cool system. It uses the Intel Optane SSDs, and they have, on the enterprise drive, they have this software-defined memory capability. So each node in this cluster has 196 gigs of physical RAM, but it also has two 750 gigabytes of these NVMEs, which are presented as memory. It sees 1.5 terabytes of memory, and we were able to get this 16 nodes for $200,000. So this system, this capability is unique to them. It's a good use of their startup money, and it provides a capability that they would not have otherwise been able to.
Patrick and Randy.
So a number of good points were made, and I'm not going to go back over them, but I'm going to try to go slightly in other ways. First and foremost, in my institution, undergraduate involvement in research is highly prioritized. It's really important for both the faculty. My faculty runs the gamut. I've got people who are just coming off that postdoc from the R1, but I've also got faculty who've been here for 32 years and still want to worry about, you know, the size of their swap files. So it runs the gamut, and you must be sensitive to that. The other point is that I strongly advise the tenure track folks to funding and not to invest it for at least 6 months. Get your feet on the ground, find out the kind of institution you're at, and then begin to have that discussion of where we're going to go forward. Oh yeah, I had to tease Patrick. You can keep mental notes. I must keep written notes, and they must be available to me. Getting future needs, the spend down, you're making a really valid point there. Those emergency calls, they come. For me, it's late June, and I've got to be ready to pull that trick off. Talked about this, but I'm at an institution in which there is no cost recovery. So at least as far as HPC, there are other elements here, but at least as far as HPC goes, I am anticipating them to bring some of the resources, but we also provide some of the resources. Yet there is no chargeback for any of that. The challenge of having this incredible breadth of skill and knowledge is something that you really have to think about and be able to adjust to. You know, you've got that person running the latest release of TensorFlow on Ubuntu versus that person who is running the same block of GROMACS code or that Fortran 77 code. You know, it's a breadth of skills and a breadth of knowledge, as well as a breadth of ages.
Yeah, so I think Chris makes a really good point about buying hardware and not buying like the usual stuff, and making sure that researchers get the specialized tools they need that will best suit what they're doing. Related to that, everyone comes into our program, they get a desktop, and that's, kind of what everyone wants to use. It's what they're used to. And so one of my goals when I build cyber infrastructure is to make it better, is to make the experience better than what they can get on their desktop. And if I can make that experience better, then they will use my solution versus their. When I build out a top for Linux, I make sure that it has all the tools they need and more, and all kinds of little bells and whistles, so that they want to go to that 32 core machine or 60 versus their desktop. And that has a lot of practical implications. When they use data on the shared resource, we can back all that data up. When they use it on their desktop or their laptop, we kind of have to rely on them a little bit to, make sure that they have their data managed and that, that they have it backed up. And when they use stuff that we provide, we can be a little more hands-on and help them troubleshoot just that one machine for just trying to troubleshoot, 36, 40 different desktops. So again, I always try to make my solution better than what they have in their hands so that they use it. In terms of faculty, dealing with faculty, my perspective is a little different because I have a secondary appointment in computer science and I'm integrated into the research team. So I'm not only the cyber guy, I'm also part of the research team. And so I kind of have this conflicting thing going on in my head oftentimes. And the way I kind of see it and work with faculty is I see faculty researchers as kind of the dreamers. And my job as the cyber infrastructure guy is to be the pragmatist and to help. So when they come to me, my job is to help them prioritize those ideas and their computational goals. So I often encourage researchers to come to me asking for the moon, asking for everything that they could possibly have. And then I sit down and have a collaborative discussion with them to figure out what's practical and what's the best use of our limited resources. There's only, me and one full-time programmer. And so we, working on this grant. And so we need to make sure that we take care of their needs and everyone else's needs in a way that makes sense. And when you sit down with them in that collaborative way, I feel like you always come away from that conversation with both people feeling like they won something. I won in that I now have a better understanding of exactly what they need and a path forward, and they win in that they understand the technical requirements of what they're asking for, and they still get some of their work done. And in a sense, they often are able to to have their scope more focused. And I think a lot of faculty really appreciate that. Again, their job is to dream, and our job is to kind of help them make those dreams a little bit more focused and a little bit more narrow in scope so that they can have a better idea of where they're going computationally. And so that's kind of the way I approach faculty.
So since we are talking about hardware and grants, at what phase do you start working with the researchers on their grants? Like, do you know them very well that you would start from the beginning designing like a specific hardware or maybe software solutions or a combination based on their needs, or like last minute where they are about to submit the grant or they already outreached the vendors, they started like speccing and then you notice mistakes in the design and like you try to fix it. So for example, in our case at UNM, when we built the science DMZ, we knew our biggest users on campus and we reached them and we asked them if they would join the efforts to be focused on grant to build such a science DMZ. While in another case, we had a group of people who already started purchasing a system and they planned on hosting it at our center without even mentioning it. And they told us about a week before submitting the grant and we were like, that doesn't work. Like, this is a bad design. We cannot integrate it into our systems. And we got involved in just like on an emergency call and tried to fix as much as we could. So how do you deal with these things?
So I'll talk about briefly the reality before I talk about the ideal. I think the reality, right, is that we often do not have as much lead time as we would like to collaborate on grants. And it's sort of like you're saying, where we might learn something with a day's notice or a week's notice, or maybe no notice because they have put together a grant and it's 4:58 p.m. and it's due at 5 and there you go. So that is the unfortunate reality. We don't have enough of those opportunities as we would like. But the ideal situation, and the one that we are working towards becoming the reality, is the Office of Sponsored Research, so that when that office is contacted by people who are interested in doing grants, even if the researchers themselves haven't necessarily reached out to us directly, they can be guided to do so by the Office of Sponsored Research. So they can be pointed over towards us and we can initiate that conversation with them. One of the things that we've done very recently, just in the last month or so, is we had a couple of instances, sort of like what you're saying, where a PO would show up and someone would be like, what is this for? Like, I have no context for this. And it's not something small. It can be for like a large workstation system or a server or a piece of lab equipment in biology or physics or whatever it may be. And what that is. So I worked with a lot of stakeholders to create an equipment intake form. So we designed it in Qualtrics, and whenever somebody is kind of aware of the need to do this. So it could be a new researcher with startup funds, as we've been talking about. It can be someone who is writing a grant proposal, looking to purchase new equipment that way. No matter what the entry point is, we are in the process of trying to guide them towards that form. And it asks them questions that we would be asking of them, but that they might not be aware of, that they need to take into account when they're speccing out a system. And so that, even just in the couple of use cases that we've had in the last month or so, that's been really helpful, because in some cases, we are able to, work with either our vendors or work with a faculty member to craft a solution to what their problem is that saves them money. So whereas before they would have gone out, talked directly to the vendor, spec'd out a PO, said, oh, this is going to cost me $12,000 for this piece of hardware. We work with them, and based on these needs, it ends up that we might give them a solution for, like, let's say, $8,000. So they've then saved, a third of what they originally thought they would have to spend. So we do try to get involved as early as possible, but the reality on the ground is that that is not always the reality that we face. But we try our best.
Before I answer the question, I want to talk about spin downs real quick. They've been mentioned twice. And I want to caution you on buying anything you want with spin downs. With the NFS and the NIH, or NSF and NIH, they tend to be more understanding of last-minute equipment procurements. But the DOE and the DOD are not so amenable to it. I've seen 3 audits triggered in the last 3 years from people trying to buy equipment at the end in the life of a grant. So be cautious with that, and maybe reach out that to be carte blanche. Now, in terms of answering the question, I insert myself into the proposal writing process as much as possible. A lot of what I've been doing over the first couple of months is reaching out and getting to know the campus. As many places as possible, I've inserted my. So the first process, where it's probably good to insert a member of your team, is in data management plans. So every data management plan on campus for us goes through the Office of Research. I'm in a separate office, however, I serve on a consulting basis. So I see every data management plan that goes through campus. In theory, I see every data management plan that goes through on campus. And so at that point, it sort of triggers me of whether something is going to be written. If you are competing for larger proposals, larger competitive proposals, a lot of them are limited by the number that can be solicited per university. So, for instance, larger NSF grants, a lot of DOE, both Office of Science and National Nuclear Security Administration proposals have a limit of 1 proposal per campus or 2 proposals per campus. Insert yourself into that process. Find out who is going after the big grants. Make yourself available. If you've never had to put together one of these large proposals, it is a very time-consuming process. I've had proposals go out which were over 250 pages in terms of the total material, go out for these $20 million multi-year center proposals. So they're looking for help. So they will gladly accept your assistance. Finally, one thing I do is reach out to your campus representative for your hardware vendors. For us, of course, we're in Texas. That means Dell. So, our Dell reps, I reach out to them and make sure if someone contacts them, that they contact us. So it's fine for people to purchase equipment without us knowing, but we would like to help out if possible. So, of course, you don't always get to insert yourself in the process, the ideal circumstance a lot of times doesn't work out, but hopefully by inserting myself and making myself available through as many avenues as possible, that you increase the likelihood of contact.
Okay, so Randy, can you tell us about your experience?
Sure. First of all, Hussein, there's interesting conversations going on in chat. If you're able to see them, you might be able to relay them across. Patrick's been answering. Um, so I operate I operate slightly differently in that I offer up a cafeteria of options and then see which way the faculty go. For instance, in rolling out our studio, it didn't take hold for 3 years, and now it's by far and away my largest computational need. Two, as a recipient of the CC Star grant, I'm just going to use this one as an example. As we've rolled out our improved network, the usage cases have changed dramatically. And so being able to keep an eye on how folks are using the altered resources is super important. As an example, a regular NCBI search that was done that took 4.5 minutes up until mid-July when we started kicking off the DMZ research network is now taking slightly less than 18 seconds. What happened? The researcher walked into my office this morning and said, oh, I'm going to change the question I'm asking in order to be able to, that now I can do this stuff that I couldn't do before. I am an Exceed champion, and honestly, I had trouble selling it because my network connection was so darn slow. That's changing now. And so all of a sudden, resources that weren't available are becoming available to my faculty. And so the use case scenarios are changing rapidly. Boy, would I love to be on campus. That's an interesting way of using Qualtrics and incentivizing it by saving them money. But that new $500,000 NMR that just showed up, I didn't hear about that until yesterday. Off to you, Patrick.
So again, my perspective is a little different here because I don't work in university IT. I'm specifically assigned to a grant, but part of the F-score grant, one of the goals is to build infrastructure. And so when we make important that we make an argument that it's not used for just us, but it's an investment for the university or the state or the region. And so so we're in year 3 of our 5-year grant, just started year 3 of our 5-year grant. And I'm already discussing with our university IT what kind of things we should think about purchasing in the next grant cycle, and that starts in 3 years from now. So I think the earlier the better. That you can engage faculty and you can engage other folks, other stakeholders, the better. In fact, before the first letters even hit the page, I think these discussions are really important. And so yeah, I think the earlier just the earlier the better.
So, are there any trust issues that you see between, like, you as a research center or as IT providing research facilities and the researchers themselves?
Are there any trust issues? I would say, I don't know that there are trust issues per se, or at least none of which I'm really aware, but about the closest thing I could say to that, and I'll keep this extremely brief, is that some researchers or departments, and I'm sure we've all experienced this, have a tendency, in some cases, be wary of centralized services. They want to run it themselves. They want the computer to be under their desk or in their lab or in a only by departmental members, that kind of thing. So sometimes there is that sense, and we do have to work with them to ensure the researchers that, no, we're not Big Brother coming to take your stuff away and kind of mandate a way for you to do something. but we want to help direct you in ways that we know can make you more productive or more secure or more whatever. So I don't know that that's so much a trust issue, so much as just, you know, the sort of very real desire to over stuff as possible, which you can understand that tendency when this is somebody's livelihood, this is their research, this is stuff that's going to contribute to their tenure or to their promotion or to subsequent grants or whatever. So it is sometimes important to work with them in mind, and that we want to work with them and not against them and try to force them down a path that they don't want to go down.
Yeah, is it on?
We're trying a new microphone, everybody. Hold on.
Testing. Hello.
I'm not hearing it very much.
Hello.
Yeah.
So I need to hold it.
Yeah, see, it's on.
What's up?
In the chat.
Is that working? Yeah. Okay. So the trust issue is something I've had to deal with at UT Dallas. Up until about 10 years ago, UT Dallas was mostly a commuter school. There were, of course, faculty members there doing research, but there's a lot of campus IT groups. There is, of course, centralized resources, but every department has their own IT group. And there's even several sort of independent contractors who do HPC support and one-man shops who maintain 20 HPC systems. And historically, campus IT didn't do researcher support. It was focused mostly on education. And that changed about 5 years ago. But institutions have a long memory. And the people who've been at, researchers at the campus were trust new faculty members who don't know the campus history have an implicit trust, especially when you start talking to them about science. So, most of my efforts have been focused on new faculty and people who've been hired within the last couple of years and to focus on catalyzing their research. And I hope that by seeing them be successful, that their peers will be less resistant to change. Also by focusing on education and grant writing support, I hope to gain more trust from the campus IT groups. This is going to be a work in progress, but hopefully something we're able to overcome in the next year or two. Chat that I'm going to go ahead and address. The question was from Brad Berkman. Have you ever had the experience that new PhDs come in thinking that they need exactly what their advisor had so that they can do the same thing they've been doing, then realize that they aren't part of that group anymore and they would rather do something else? Illustrate with stories. Yes, this happens quite frequently. When a new faculty member comes in, and as we talked about earlier, especially tenure track, they're under time pressure. And unfortunately, most of our funding, so software is an afterthought, or it's something which people are resistant to change. Now, I'll talk more about this in my talk tomorrow afternoon when I talk about mapping research requirements to software choices. But if you have a faculty member who's working with old code they brought over from their previous research group, something that is not open source, or something that's not licensed appropriately, or something that doesn't provide support, bit rot is a real thing, and bit rot rates are increasing dramatically as systems become new. The rate at which a code ages these days is much faster than a code that aged from 10, 15 years ago. So, when someone makes the transition from PhD to a new faculty member, it really is a good opportunity to clean sheet code, to sit down and try to figure out if there's an alternative for them, or if there is a community code they could use, or if it makes sense to start developing their own code. the last choice makes sense for a lot of programs, but it's one that's hard to swallow. Again, very few places offer tenure on software. Very few places will say, wow, you have no publications, but hundreds of people are using your software. Good work. So you really have to weigh the advantages and disadvantages of working with a code that has a questionable pedigree. And more often than not, especially if you're sort of working on the high performance computing, large scale parallel programming, it's worth clean sheeting the code. And I offer support for that, and I'm helping several faculty members right now design new codes.
Hi, I'll come back at the trust issue because I think there's a couple of interesting points. First of all, shortly after I was hired, the Dean of Faculty and I reached a conclusion that one of the ways to build up trust, which was not good, was to move my office out of ITS and into the academic buildings. In point of fact, my office by design moves from department to department every 2 years. Being able to be seen, to break down that them versus us, as was mentioned in the beginning of this workshop, is crucially important, that they see that we're part of them. That said, it's important to note that it's much easier for me to build up that trust with the traditional domains, that is the sciences, the hard sciences, even psychology, we can work it out pretty easily. But as the demands have begun to increase from the non-traditional domains, that has been a real challenge for me, and something that I don't have a clear path on. And would love to, there are other people out there who have found easy ways of interacting with research. It would be helpful. The final thing was in regards to what was asked by Brad. I am a little bit lucky in that as part of the tenure decision, it is crucial that the faculty member do original research. That is to show independence from the either PhD advisor or postdoctoral person that they used to work with. And so I try to leverage that to move them on from, that old MATLAB library that they still use that isn't supported anymore. I'll pass it off to Patrick.
So on the trust question, I think I'm the wrong person to ask. I think you should get my colleagues on the line and ask them if they trust me. I don't perceive that there's a problem. In fact, I think we have a great level of communication and trust. And I think that one big reason is that I always try to underpromise and overdeliver. I think one of the quickest ways to erode trust is to not be able to say no, is to promise the moon and then give them nothing. And I think that by managing expectations and delivering on those expectations is the best way to build trust with the researcher. So again, I always try to underpromise and overdeliver, and then they're always happy with what you're able to provide, and be able to say no when you know you don't have the resources to be able to do it, or you're going to submarine another project because you oversubscribe to someone's desires. So you have to have kind of a big, I think having a strong backbone actually helps build trust a lot of times. To answer, Brad's question is interesting to me because I often have the opposite problem with that. So, for example, our last grant really built on the previous 5-year grant. And so we had a lot of modeling code and software development that had gone into that previous grant, and we kind of wanted to leverage that as we moved into the next stage. And in particular, our hydrology modeling software, we had added a bunch of new features to it. We did like stream bank erosion and did some neat routing stuff with streams, and all kinds of cool stuff. And we get the new grants, so a new set of postdocs and grad students. And all of a sudden, some of them wanted to change, the modeling software. And, so we had we and me and the faculty had pushed back a little bit and, to say, well, to kind of save that investment. So I think more often I have the opposite problem that, new faculty, students, whatever, come in, they have their own technology that they're familiar with, and it's not what we've invested in, it's not what we're familiar with, and it's not what we're able to have to have that discussion and usually meet somewhere in the middle of, how can we leverage the stuff that we've, the interesting research we've done so far, and not, just toss it out into the wastebasket for whatever new technology this new person has in mind.
So we got about 5 minutes before the end of this session. And my last question would be when do you say no? Or when, we know our limits, how many employees do we have, or the power of our machines? What do you end up doing if you cannot provide what they need? Do you move them to national resources, or do you move them to the cloud?
All right, okay, there we go, it's on. So since we only have 5 minutes, that's about 1 minute per person, so I'm gonna keep it exceptionally brief and say that, I've actually given a talk on how to stop saying no. I can't stand saying no, and I don't feel that that's a very useful approach. I do know that often resources are zero sum, where if you want to start doing something, you have to stop doing something else. But I try to avoid that situation in as much as any resources are under my control, which aren't a huge swath of them. But in terms of working with the teams, I try to get to yes as much as possible. Henry actually is famous for saying, don't say no, instead say yes if. So that's a much more productive conversation to identify the resources that would be needed to support something in an effective and comprehensive way. So I would rather have that kind of conversation to say, sure, we can do that, we can accomplish that, and I understand why that's a good outcome if we're able to do A, B, C, D. So that's where I'd like to be instead of saying no.
I agree totally with that sentiment. I don't like saying no. Instead of saying no, I try to rephrase the question. And I try to rephrase the question by simply not negating it, to try to come up with something that is more amenable to our implementation or is more long-term sustainable. One of the things you need to be very careful with, especially when working with restricted budgets these days, is being a victim of your own success. That is, you come up with a perfect solution that has this large commercial license associated with it, and you make it a campus resource, and then all of a sudden it becomes too popular for you to afford. So I caution saying yes to too many things, but at the same time, try to rephrase the conversation to something you can support.
So we're going quickly here. My approach to the avoiding saying no and saying yes if is to be very clear about how I triage all the requests. I mean, if I were to try to accomplish all the things that people would like me to do, my wife would never see me. I only have, 120 hours in a week to accomplish my tasks. So I'm very clear that it is the class, the big class, that wins, and that research comes when I can get to it. That is to be very clear about where the stack is and when we can get to it in the calendar year. That building that temporal schedule and giving them a heads up of where they are and keeping them up to date. Talk to them, send them an email. Hey, I can't get to that task for another 3 days is so essential.
Yes, great comments from everybody. I agree with all the sentiments on this, on the no, yes, if discussion. I think be honest and upfront is by far the best policy. In terms of your question, Hussein, about limited resources and where to put people, or where to send people. as a general rule, I try not to buy things that I need to maintain. You know, again, limited resources. If I have to spend resources maintaining stuff, that's less resources I have to do research and to help the researchers. So as much as I can take advantage of or you know, cloud kind of solutions, I try to do that. So that's kind of my general rule all the time, not just when I'm resource limited.
Thank you. Now, there is one note that Bob Freeman brought up on the Zoom land. It's like we should support all research computing because sometimes we get lost supporting the big machines and the big applications, and we forget about utilizing, maybe solving a lot of problems on the user's end on their desktops. And his note was like, support everything from the desktop to the data center. And with that, I would like to thank our panelists and close this and this.